Hello students, it is the second lesson of the flipped classroom. In this video, I will demonstrate three formulas for you. The first one is a to the power 0. Do you think that a to the power 0 is quite new for you? Now before I give you the answer, let's investigate. What is the value of a to the power 0? Now I'll give you some easier problem first. The first one is a to the power 3 is divided by a to the power 3. Without using the formula, we can expand it out. A to the power 3 means a times a times a. Similarly, for the denominator, a times a times a. So, if a is divided by a, we can take the division. It's equal to 1. Similarly, for the second one and the third one, they are all 1. It means that the value is 1 times 1 times 1 is equal to 1. It means that a to the power 3 is divided by a to the power 3, the value is 1. But some students may think that, can I use the formula? Which formula? Now, let's check. This is the formula 2. If we use the formula 2, a to the power m divided by a to the power n, we can use the index m minus n. Similarly, if you can repeat this question, we can use the formula a to the power 3, 3 minus 3. It means that it is equal to a to the power 0. Therefore, we can conclude that we can get the result a to the power 0 is equal to 1. Is this really the case? Let's check. Another example, a to the power 4 to a to the power 4. A times a times a times a. Similarly for the denominator, the answer is 1. If use the formula, we can say that 4 minus 4 is the index. So a to the power 0 is equal to 1. Therefore, in general, a to the power 0 is equal to 1. Very good. Please write down it on your worksheet 4.2. Do the formula 2 for you. This formula is a to the power n. What is the value of a to the power negative n? Let me give you some example. Let's say a to the power 3 divided by a to the power 5. What is the value? Let's go. Let's repeat the same procedure as before. In the numerator, there are 3 a's. In the denominator, there are 5 a's. Let's divide it 1 by 1. We notice that in the numerator, it is 1 times 1 times 1. And in the denominator, there is 2a left behind. So we have 1 over a squared. But if you use the formula, which formula you have learned before, it is the formula 4.1, the formula 2. We can directly get out the answer, 3 minus 5. Therefore, on the left hand side, it is a to the power negative 2. But on the negative side, on the right hand side, sorry, it is 1 over a squared. What do you notice? Yes, very good. It means that a to the power negative n is equal to 1 over a to the power n. Yes, very good. It is the second formula for you. Okay, now the last one. It's quite good when you are dealing with some other problems. So I make it as one formula for you to remember. It is the value of a to the power negative m over b to negative n. How can we deal with this kind of problem? Now, in the denominator, it is b to the power negative n. In the numerator, it is a to the power negative m. We can do it one by one. And then you must remember this result. For the a to negative m, as I said before, it is equal to 1 over a to the power m. For the denominator, it is quite similar, over 1 over b to the power n. It is quite complicated. How can we simplify it? It's very easy. It means that it is divided by 1 to the power 1 over b to the power n. Let's change the division sign into multiplication sign. It is 1 over a to the power m times b to the power n. So the result is b to the power n over a to the power m. So now remember, a to the power negative m over b to the power negative n is equal to b to the power n, a to the power n. Can you remember it? It is difficult. Maybe you think it very difficult. Now, I'll give you a shortcut to remember this formula. It's just like a lift. If you move the letter a to the power negative m, b to negative n, we just take the numerator a to the power m, put it inside, or maybe put into the denominator. It becomes a to the power m. How about b to the power n? We put back to the numerator, b to the power n. It is more simple for you. I'm going to do the question number 1a for you first. It is quite simple for this problem. Now, the first round bracket, x to the power negative 4, is equal to, using the formula 2, x a to the power n, negative n is equal to 1 over a to the power n. So I simplify it first. It is equal to 1 over x to the power 4. Similarly, for the second round bracket, it is equal to 1 over h to the power cube. And then, after simplify, the numerator is 1 times 1, so it is equal to 1. And the denominator, x to the power 4 plus 3. Therefore, it is equal to x to the power 7. But some students may think that it is easier for me to use another method so that I can get the same result. Let's go. He used the formula in section 4.1. X to the power negative 4 times x to the power. He tried to make it as x to the power negative 4 plus negative 3. So the result is x to the power negative 7. And use the formula 2, this one, to rewrite x to the power negative 7 as 1 over x to the power 7. Which one is simpler? Now, in the later examples, I will use this method rather than this method because this method is quite complicated. Remember, I will use the right hand side. For question 1b, you can see that there is a small round bracket, and outside the bracket is power 3. As we stated in 4.1, we can remove the small round brackets by using the formulas you have learned before. X to the power 3, and then y to the power negative 6. How can we get negative 6? It means negative 2 times 3. But what is the value of x to the power 0? In section 4.1, we didn't know it. But after section 4.2, you know that x to the power 0 is equal to 1. Therefore, the value is 1. And then finally, we will make the negative index into a positive index by using the formula 2. Therefore, the answer is x to the power cube times 1 over y to the power 6 times 1. And the answer is x to the power 3, y to the power 6. In question 1c, you can also see that there is a small round bracket. And outside the bracket, there is the index negative 1. We use the same formulas. Remember, the negative value means that there is a letter 1, negative 1 here. So I repeat the question by copying this, but I make directly out the negative 1. And then you use all the formula we have learned before. For the value of negative 1 to the power negative 1. How about this? X to the power negative 2. This one, negative 3 times negative 1, x to the power 1 to the power 3. What is the value of negative 1 to the power of negative 1? Let's go. It means that it is 1 over negative 1 to the power 1. What is the value of x to the power negative 2? 1 over x squared. Yes, very good. And last one, nothing changed. So, finally, the answer is negative 1 times 1 over x squared y to the power cube. So, after simplify the answer is negative y to the power cube over x squared. In question 2a, now you can see that inside the small bracket there is a number 1 in the denominator, number 1 in the numerator, number 5 in the denominator. So use the formula to expand it out first. 1 to the power negative 3 and then 5 to the power negative 3. But how can we simplify these so complicated expressions? Remember, we have a formula for you. Yes, this one. We can change the position of the number into numerator and the denominator. We can interchange their position. It means that we can move 5 to the numerator, and then the negative index will become a positive index, 5 to the power 3. How about this one? Put it back into the denominator, 1 to the power 3. So the answer is 5 to the power 3 over 1, and the answer is 5 times 5 times 5. The answer is 125. Now in question 2b, it is quite similar to the question number 2a. We can see that there is a negative 2, but with a small bracket. Outside the small bracket, there is an index 0. So we can directly use the formula a to the power 0 equal to 1. Therefore, I immediately get the right answer. It is 1 for the negative 2 to the power 0. How to deal with the 1 over 2 to the power negative 3? We repeat the same procedure as 2a. It means that 1 to the power negative 3, 2 to the power negative 3. But there is negative index. We change the negative index into positive index by interchange their position. Now remember, 2 to the power 3 negative 3, put it back into the numerator. It is equal to 2 to the power 3. 1 to the power negative 3, put it back into the denominator, 1 to the power 3. How about this? Just copy the number 1. So the answer is 1 times 2 to the power 3 over 1. and then 2 to the power 3 means 2 times 2 times 2 is equal to 8. Question 2c is quite complicated, but there's a division sign here. So the first step we have to do is change the division sign into a multiplication sign first. It means that don't do anything except changing this division sign. So nothing special, just copy the answer, but the division sign, it will be changed into 1 over 2 to the power negative 5. And after that, we can simplify the expressions. For the first one, 3 to the power 0, the answer is 1. Yes, very good. 4 to the power negative 3, repeat the same procedure as 2a and 2b. We can expand it out as take out the bracket, remove the bracket, 4 to the power negative 3, and then 5 to negative 3. And the last one, we just copy it. As you can see that there are so many negative index. How can we remove the negative index? Can you remember? Yes. We have an important tool for it. For question number 3, we can interchange the position so that the negative index become positive index. Now, it is very useful. Now remember, so we start changing the position. 4 and 5 interchange the position. 5 to the power 3. 4 to the power 3 put back into the denominator. It is 4 to the power 3. And 2 to the power negative 5 put back into the numerator. 2 to the power 5. 1 put back into the denominator. Okay, now let's go. What is the value of 5 to the power 3? 5 to the power 3 means 5 times 5 times 5. 125. The other one, you can do it by yourself. So the answer is 125. 4 to the power 3, it is 64. 2 to the power 5 is, now you can find it out by yourself. It is equal to 32. After simplify, it is 125 over 2. After watching the question for number 1 and number 2, you have to do some classwork for number 3 and number 4. Later I will check the answer with you. Now, let's check the answer for 3a and 3b, 4a and 4b with you.